Great. Thank you, Bryn.
No problem.
Good morning, everybody. Thank you for joining us bright and early for this latest edition of Code Trainings. My name is Steve O'Malley. I'm a lead engineering consultant with Efficiency Vermont. And as you can see from the title, we're going to be talking about multifamily new construction today. And as a shameless plug, I want to remind everyone that we do have a multifamily new construction program at Efficiency Vermont. We provide technical uh, expertise to projects on the consulting side. We also have financial incentives available. So if you haven't worked with us before on your multifamily project, please consider us on your next one. Okay, so a couple little housekeeping things. I do need to mention that, um, let me get that out of the way. Put that there. Do need to mention that the material contained in this presentation is information which is proprietary and copyrighted by ICC, and that this information has been obtained and reproduced with their permission. The acronym ICC and the ICC logo are trademarks and service marks of ICC, all rights reserved. Okay, so let's get into this. Target effective date is July 1st, 2024. So we're on the clock here. We're March 31st. So in just a little bit, we're going to be seeing the new code being rolled out. And do RBs and CBs have the same code version trigger? That's a great question. They both have the same effective date, but the answer is they have a different trigger essentially in terms of which code you're going to follow. Are you going to follow the 2020 code or the 2024 code? And so for your CBES buildings, that's going to be your 4 stories or greater multifamily or mixed use buildings. It's going to depend on the building permit application date. And for RBs, it's going to depend, just as it was in the previous code cycle, it's going to depend on the construction start date. And what's something here I want to mention? A little fun fact for you here. You actually won't find that information in the code book itself. You have to actually look to the RBs and CBs certificates, and that's where that language lives. And a caveat on the CBs. So you can get your building, if you had your building permitted prior to July 1st, 2024, you have 6 months in which to start construction of your building. So again, code effective date July 1st. If you're permitted under the 2020, you have to begin construction prior to December 31st. Otherwise, I think the writing on the wall there is that you would have to then revise your design to comply with the 2024 CBs. Okay, and then do I follow RBs or CBs? 3-story slab on grade, we all know that's RBs. 4-story building, we all know is that CBs. 3-story building with parking garage under. And the answer is it sort of depends. If the only thing you have in your parking garage level is an elevator shaft and a stairwell shaft, and there's some unconditioned mechanical rooms, then it would fall under RBs. If you have a 3-story, if you have 3 stories of multifamily above a parking garage and you happen to have any kind of conditioned space down there that's meant for occupancy, like a laundry room or a community room, something like that, that would flip you into having to call it a 4-story building, and you would want to be designing to CBs. And stretch code for CBs, it's going to be just like 2020. There is no stretch code in CBs. And for RBs, excuse me, and what about Act 250 projects? And the answer is still no there as well. What about RBs? Different. So yes, RBs does have a stretch code, and things like Act 250 projects and municipalities that have adopted the more stringent stretch code. And community that comes to mind is Heinsberg that is doing that. Okay, so why don't we just start plugging right into a lot of the design elements that are going to be changing with 2024. We'll start with the envelope. And as I'm going through this today, I'll kind of be bouncing between RBs and CBs, and at times trying to talk about both of them where the two align well. So changes from 2020, adjustments to most U-value requirements, better alignment between RBs and CBs. You'll notice I'm careful not to say perfect alignment or just alignment. It's better alignment. There are still plenty of areas where they don't necessarily line up too well next to each other. So some better alignment between the two codes. Windows are now U 0.30. In the previous code, if you had a CB's building, you had a U value for an operable window, you had a U value for a fixed window, and then you had the RB's values for windows as well, which all three of them were different. So now it's, if you're building a multifamily building, regardless if it's 3 stories or 4 stories, there's your window requirement. And similarly, there is one air leakage target for both RBs and CBs, regardless of the height of your building. And you'll notice it's getting more aggressive. So here we go, air leakage, 0.15 CFM50 per square foot. And I say regardless of building height here, because if you're building a commercial building, not multifamily, the air leakage requirement testing protocol is that you would be testing to CFM 75. And in order to do a couple of things here, the Department of Public Service and consultants weighed in and determined that using CFM 50, regardless of building height, was a smart thing to do. And a lot of it has to do with those of us who have been in the building science community, those of us who are architects and other designers, those folks who are building and constructing buildings, folks who are testing buildings. Everybody is used to this common language of CFM 50 when we're looking at our multifamily buildings. And to start testing at CFM 75, it would really throw a wrench into that for a lot of people in terms of being able to think about our buildings and being able to compare buildings. Like, how do you compare a CFM 75 to a CFM 50 building? It's not something that would come naturally. And so I applaud the writers and developers of the code for adopting a CFM 50 standard between both RBs and CBs. And again, 0.15, that's a good target, meaning you're going to have to spend some time thinking about your building and thinking about your air leakage details and communicating with staff in the field about the air leakage details to achieve this number. It's not just going to sort of happen organically. I don't think it's onerous, because we are certainly seeing plenty of buildings that are falling well under this 0.15 metric. So it's certainly still very, very achievable. I want to stress that to people. It's not a number to panic about. Another envelope requirement, although it's not related to insulation or air leakage, et cetera, but there is a solar ready zone has to be defined. I'm just calling that out here in the building envelope section, just because it's something that it's on your roof. And that's something we'll talk about in a little bit. So here we are, building envelope requirements. We'll spend a little bit of time here on this slide. If we look at going left to right, on the left-hand side, you'll see component, and that's straight out of the CB's book. And then you're going to notice that the next 3 columns over, the green column is the 2020 CB's value, the blue column is the 2024 CB's value, and then the orange column is the 2024 RB's value. And you'll see that they're close in most cases. They're the same in some cases. And I'm not sure why they arrived at this decision that they were going to be sort of the same, but not quite the same. So you'll notice that insulation above deck is a slight difference, U 0.022 versus 0.02. And if you look over to the far right in the 2 rightmost columns that are not colored, you see example assemblies. And so for the CBs, it's an R45 is the code requirement, and for RBs, it's R44. You know, big picture, that's really not going to change your design. No one's going to be thinking about necessarily that one incremental 1R value there. When we look at the attic, they have the same U factor. So it means essentially effectively an R49 blown attic. And what else is of interest here? You can see for walls above grade, wood framed and other, that it's actually a fairly big difference between the two. And I'm stressing the U values here because what I want to point out is that when we're looking at these tables for our values for our assemblies, it's the U value is the value that you need to hit to meet code. And in the old code books in 2020, they had one column that gave the U value and then had another column that gave an R value. And the vast majority of people I spoke with sort of walked away with looking at that code book of looking at that R value and that assembly that was presented and assumed that's the assembly that I have to build. And it was really, you could build the assembly however you wanted, you just needed to hit the U factor. And so they changed their language in the code, which is great. So now they're actually calling it out as example assemblies to the right, just to let you know that, hey, here are a couple of ways that you can go ahead and know that if you build this assembly, you're going to meet that posted U value that you see to the left. One of the big things that I see in here that people, particularly people who have designed 3 stories and fewer in the RBs category, is that now you cannot build a wall assembly that has no continuous insulation. Previously, there's always been a package available to design to that was going to allow for a cavity only option. And now it just doesn't work with the U value that is presented. It's unless you would have an incredibly thick wall, which there are a lot of reasons not to do that. You're going to be effectively forced into incorporating some type of continuous insulation to the exterior.
Hey, Steve.
Yes.
Just a quick question, and to confirm that the topic of today's training is for multifamily projects.
Correct. We are talking multifamily projects.
Great, thank you.
Maybe I'll start every other slide with that, in case we have people who are joining.
Yep, thank you.
But yes, we are focusing solely on multifamily buildings today. Let's see, what else do we have here? Below grade wall. Here, you're going to see that when we look at the energy code, there's a C factor, C 0.048, for instance, for the 2024 CBs. And then you'll notice the example assemblies is R20 continuous insulation, for example, under CBs. The C factor is not the same as a U factor, whereas the U factor, we've all done, or a lot of us have done that calculation when you're looking at an assembly, calculate the U factor for it. You can't do that with a C factor. It's not the same analysis. That would involve more type modeling type software that would be necessary to do that, because it's going to take into things like soil gradient temperatures, et cetera, that again isn't any simple linear math that we can just do on a calculator. But I do want to point out that below grade wall, it looks like it is the same between RBs and CBs. It's essentially effectively something equivalent to R20 continuous. Joist framing. So for floors, we're talking floors above unconditioned space. They're very similar, 0.027, 0.029. One big change that I want to point out for the 24 cycle is unheated slabs. The requirement in the 2020 CBs for an unheated slab was that there needed to be R10 continuous insulation beneath the entire slab. regardless of the size of the slab. So we see some fairly large multifamily buildings, and that was a sticking point on design in terms of added a lot of cost, and how much value are you getting out of the very center core of that slab being insulated. And I again applaud the people who wrote code that they've essentially reverted the unheated slab requirement to go back to just doing insulation 48 inches below. So essentially take care of your slab edge and then run your insulation down to the top of your frost wall. And the thing that did increase is the R value. So before it was R10 and now it's R20. And you'll notice that Arby's, there's a slight, they have another option as well. Under Arby's, it says you're allowed to either do the R20 for 48 inches, or you could do R15 at the edge and R7.5 beneath the full slab. And heated slabs, there is agreement between Arby's and CBES, and it is now the requirement is R20 for that down the frost wall, plus an R15 beneath the full slab. Okay, so a couple things that I wanted to highlight about windows and doors. This is an interesting one to me. Up to 15% of glazed fenestration per dwelling unit shall be permitted to be exempt from U factor requirements. And I don't know where that came from or what conversation led to that that being added into the code. If anyone on this webinar this morning knows the answer as to why that got worked into the code, I'd appreciate hearing from you.
Steve, we do have a question before you get
Yes.
into windows and doors too much further. Do you know why these are suggested wall assemblies? They don't seem to align with best practices in terms of building science. For example, don't we want R12 CI as a minimum?
Yes, the answer is yes. So two things. One is absolutely that the example assemblies will line up with that U factor. So then the person asks a great question. So are the proposed assemblies actually a good idea from a building science standpoint? And so if we're looking at that wood framed wall, we can see under CBES both examples. The first example there is for a 2x4 wall. It's saying you'd have R13 minimum cavity insulation plus R16 continuous. We know that's going to be solid from a building science standpoint. The other example they give is R19 cavity. So here we are talking about a 2x6 wall plus R12 continuous. We know that's going to be solid from a building science standpoint, as well that R25 continuous. And so now I want to divert your attention over to the Arby's side. That very first one, well, and the second one to some degree, it's saying R21 plus R5 continuous. And yes, it's from a building science standpoint, everything we're taught and have learned is that in our climate zone, we really should have a minimum of our, the magic number I've seen is 11.75. How you get to that it's kind of comical because no one's ever going to find a product on the market that's R11.75. But we all have sort of adopted R12 as sort of the standard around Vermont for building if you're going to have a 2x6 wall with vapor open cavity insulation. You'd want a minimum of R12 to the exterior. In the Arby's handbook, I haven't seen what that's going to look like yet, but there will be a handbook as in previous years, and it will show there are going to have example assemblies. And I believe when they're talking about doing something less than R12 to the exterior for continuous insulation, they are going to have details that are going to be considered, I'll say, safer. They're going to include things like a smart vapor membrane on the interior of the wall. So I think we would still be in, if we're in conversations, we would be promoting R12 continuous, but there are builders who don't want that thickness of insulation to the exterior of the buildings with how they're detailing or siding. And I'm, again, best guess that that is in there as to provide here's an example of something that meets the U value. You could detail your building like that, but you have to be incredibly smart about how you're detailing it. And you have to be incredibly smart about how you're going to handle air leakage, et cetera, and how you're going to manage humidity on the interior of your building. So if a builder came to me and said, I want to build an R21 plus R5, and said, we're not willing to put R12 to the outside, I would work with them to say, well, okay, here are the things that you want to do and be considering if you want to give your building the best odds of not having issues. I hope I answered the question. That was long-winded.
Thanks, Steve.
If I didn't, please post a follow-up question. But that's a great observation. Windows and doors, so there's that 15% glazed fenestration exemption. And then there's this interesting one side hinged opaque door assembly up to 24 square feet in area is exempted from the U factor requirements for doors. Again, I'm just letting you know that's in there. Dwelling unit enclosure testing. So this is something else we've also heard described as compartmentalization. And something that was new in the 2020 CBES that was not included in the 2020 RBs was this idea of compartmentalization, and the idea that there should be an effort to air seal between dwelling units. And the primary benefits would be things like indoor air quality. When we think about your neighbor who might be smoking, who's not supposed to be, or the neighbor who cooks stinky fish all the time next to you, you'd appreciate having your dwelling unit air sealed from your neighbor. And there are actually some energy benefits as well. Really, really, really challenging to measure. But when we think about our buildings, and we think about stack effect, and we think about our buildings acting like a chimney where cold air wants to come in at the bottom of the building and wants to exit at the top, that if we compartmentalize our dwelling units within the building, it's going to retard that stack effect. So is it going to be a massive effect in terms of energy savings? No, but it will contribute. And the metric that is in the 2024 CBs, and again, it's going to for both CBs and RBs, so it's great. Now, whether you do a 3-story or 4-story building, you've got to do this dwelling unit enclosure testing. And the metric that needs to be achieved is that air leakage shall not exceed 0.15 CFM per square foot tested at 50 Pascal. So it's the same value as the whole building shell. And so one thing I want to point out to you is that in the 2020 CBs, this value was 0.35 CFM 50 at per square foot, which was a readily achievable number. Some work had to be done. You know, if you made sure that you had sealed off your tub enclosure from the unit above, you know, the big things. If you did the big things, it was an achievable number. And now this is a number that's going to force people to do a little more. This is going to involve some more targeted thought about air sealing units. It's going to be, you know, if you have sheathing between party walls, like sealing those joints, sealing things like bottom plates to the floor sheathing, etc. Because 0.15 is a pretty aggressive number. And to be clear, Efficiency Vermont does not provide dwelling unit enclosure testing. This is something that's required by code, and so we encourage architects, builders, developers, owners to contact EEN contractors that are doing this work, and we're happy to provide contact information for the folks that do it in your area.
Steve, there's a question.
Sure.
Would air leakage impact sound attenuation?
Yeah, it will. So it'll help on the sound side as well. So it's a good thing for tenants. It's going to be a challenging thing to, I think, for the first few buildings. I saw it a challenge even at 0.35 for the first few buildings because it was something new to have to consider and be thinking about. And now that the metric has dropped to 0.15, it's going to be an even a bigger lift for people to try to get their heads wrapped around. Okay, what exactly do I need to seal in my apartment to get to that number without going crazy? Without encapsulating every apartment in spray foam, for instance, to try to hit the number. So there's going to be, I think, a steep learning curve for those first few intrepid buildings that are going to fall under the 2024, where and we'll be part of. We will enjoy being part of that, being a sounding board and a thought partner in being in the field and trying to look at these units and discuss ways that we think can effectively air seal to get to these metrics. Anything else I wanted to say there? Just be aware that you're going to have to hire contractors to do this work, and it's probably going to be a good idea to schedule in early to do a mock-up of a unit, and it might involve using plastic sheeting or something to sort of close off the unit if it needs to be, for instance, depending on how your party walls are constructed. But I think what we're going to see is some type of mock test up early in the process, so that construction crews can move forward confidently. That once they start doing their air sealing in one unit, they've got a plan and a process that they're going to follow for every single unit as they go through the building to ensure that they're going to hit the number at the end of it. Testing requirements have changed as well. So if you have, I think in the 2020 CBES, it was something like 10% of units were tested. It didn't really talk about the size of the building, but now it's going to be, if you have a small building, fewer than 8 units, it's going to be, you need to test all the units. If you have more than 8 units, you're going to test 20% of the units. And within the 20% of the units, it has to be a smattering. It has to be, a top corner, a bottom corner, a middle unit, a middle floor unit in the middle, etc. And another important distinction here is that it can't be somebody materially associated with the project that's performing these tests. It makes sense. It's essentially, you need to have a third party in there that's going to be providing this compartmentalization testing. It can't be your builder. It can't be someone from the architect's office. And as I said before, Efficiency Vermont does not provide the service because this is just something that you need to do for code. Okay.
Steve, another question.
Yeah.
Is 8 the minimum regardless of number of units? So if there's a 30 unit, would it be 20%? Would be 6?
I don't recall. The fact that I just wrote test 20% of units, I have to get back. When we will send out a PDF of these slides. And Bryn, if you could just make a note of that question, please.
Yeah, totally.
And I will verify that, and we'll put that in the email, or I'll put it in the slide, and I'll also call it out in the email.
That's it for now.
Okay. No, great question. And so I should point out that this isn't my full-time job. So I'm doing my best here at interpreting code and being a resource to you all. All right, CBES, solar ready zone. This is great. We've got alignment between RBs and CBs, so it's the same requirement. And the solar ready zone is described as being located on the roof. It doesn't talk about being on the ground anywhere or being at an offsite location, et cetera. For buildings oriented between 110 and 270 degrees of true north, or buildings that have low slope roofs. And the code calls out that not less than 40% of the roof area shall be designated as a solar ready zone. And it should also be called out that it doesn't have to be in one area. So if you had mechanical equipment in one spot or in a couple of different areas and you couldn't get one particular space on the roof that comprised 40% of your roof area, you can have separate subzones on the roof that are designated as solar ready. There is an exception for the solar ready zone, and I'm hoping I think I have that on another slide coming up. But so some of the things that code's telling us about the solar ready zone, that it has to be called out ahead of time in the construction drawings. And so someone's gonna have to spend a little time looking at the roof loads, so that needs to be specifically called out in the civil drawings. Drawings will indicate, they call them interconnection pathways for conduit. So essentially, you're effectively going to have some spaces where you're going to, where's the electrical going to come down from the roof and get down into the building. So that's got to be designated. And then here's the other thing, is that an electrical energy storage system ready floor area. And so this is something that I would imagine is potentially, if I'm thinking the 3-story above a parking garage, it's at the parking garage level. And it's going to be for the idea, again, there doesn't have to be energy storage installed at the time of construction, but there has to be space for future energy storage. So again, whether you're doing battery, or, I mean, it could even potentially be hot water if you are using an air to water heat pump. But somewhere that has to be designated in the drawings. So more about solar ready zones. The electrical panel shall have reserved space to allow installation of circuit breakers for future solar electric, and breakers for the future electrical energy storage system. And again, so it says it must have reserved space. It's not saying you have to put in the breakers today, but it's future proofing the building for electrification. Okay, here I did. I knew there were some exceptions for the solar ready zone. So if you already have on-site renewable energy, then code isn't going to require you to be adding more. If your building is shaded, there's a taller building right next to you, for instance. If the solar ready zone is shaded 70% of daylight hours, you don't have to. If incident solar radiation available is not suitable, that can be for a handful of things. Maybe you've got power lines, et cetera, that are nearby, that are shading your roof. And then this one, extensive rooftop equipment, skylights, vegetation, other obstructions certified by licensed professional. So if there are, well, again, it's going to be up to designers and owners to determine whether or not the solar ready zone applies to their building or not. And so there's that sort of catch-all. So if you've littered your roof with air source heat pumps, you may not have room for a solar ready zone, for instance.
Steve, is this the same for RVs?
Yes. Yeah. Okay. So let me back up. So I go see. I just want to see something. Yeah. Okay. Thank you for pointing that out. I need to make a change in my slide. I should just say solar ready zone, because this is truly both RVs and CBES have the same requirement. Good catch. Okay, a little bit about mechanical systems. So here I'm sort of calling out CBES separately. because there are some slight differences. So for ventilation, CBES says meet ASHRAE 62.1 in general. Whatever commercial building you're building, ASHRAE 62. And except it'll say all residential occupancies. And it says, see the ventilation requirements of section 304 of the Vermont Residential Building Energy Standards. So this is great. We just have one set of standards that we have to think about when we're considering ventilation in our multifamily buildings in the units. So that's lovely. CBES also says that dwelling units shall have ERVs, and that ERVs shall have a 70% recovery efficiency at heating design and a 60% enthalpy recovery efficiency at cooling design conditions. And they do have an exception. They say systems with a minimum sensible recovery efficiency of 75% at 32 degrees Fahrenheit at design airflow. And what I think they're getting at here is if you had an application where you really, really, really wanted to install an HRV instead of an ERV, they're saying just make sure your HRV is 75% efficient. They're on the recovery efficiency side. I think that's what the intent is there. Okay, and now slight contrast, Arby's says that just install a whole house balanced ventilation system with a minimum 75 SRE and 1.2 CFM per watt, etc. But Arby's, the Arby's code is really thinking about small, single family dwelling sized ERVs when they're talking about SRE of 75 and that 1.2 CFM per watt. So I'm not sure how this is really going to play out when we get to designing these buildings, because when we get to large central ventilation equipment, think rooftop ERV, and we're talking thousands of CFM because we've got a large 3-story building that we've got to get air to all the spaces. To get a piece of equipment that has a 75% SRE, seasonal recovery efficiency, that's rarefied air. There's a couple and they're really expensive. So I don't think that's what the intent of code is. So if I go back to the CBES ventilation and we look at a 70% recovery efficiency for an ERV, that to me is what makes sense in terms of available equipment and not breaking the budget to get balanced ventilation in our building. So I don't have a great answer for you there on that one. And maybe that ends up being something we as in the design community, I'm talking about we collectively, meaning the architects, mechanical engineers, et cetera, that if we have an Arby's building, that we're just writing to the Department of Public Service to say, hey, it's a very large piece of equipment. We're installing a 70% piece of a 70% efficient piece of equipment. Is that going to be acceptable? And asking for a variance. That's how I think we should probably play that out. Because I don't think, yes.
And as you kind of get through this section, just curious if there is any indication as to which year ASHRAE
2019.
Okay, thank you.
It's funny because here we go. The nice segue. The very next bullet point here. So RB says, do this: install a whole house balanced ventilation system with a minimum 75 SRE, or follow ASHRAE 62.2 2019, or follow passive house ventilation requirements. And I believe both CBs and RVs now are referencing, when they're talking ASHRAE, whichever ASHRAE standard is, it's the 2019. I will also point out that in terms of the flow rate that we need to install for our multifamily buildings, that Arby's historically has had I'll call it the prescriptive approach for the flow rate, not the efficiency of the equipment, but the flow rate, that they had this simple little formula, which was 15 CFM plus 15 CFM per bedroom. So it was great. If you had a 1 bedroom apartment, you wanted to provide 30 CFM per apartment. If you had a 2 bedroom apartment, it was 45 CFM. And that still is in play. It doesn't spell that out. Interestingly, it doesn't spell that out in the actual code. It will show up in the handbook. And I did get confirmation from folks at the Department of Public Service that that still is a viable design strategy. Because what we find with using ASHRAE 62.2, which is a fine standard to use, your flow rates in some cases almost double. So you could be looking at, for a 1 bedroom apartment, it might be 60 CFM that ASHRAE 62.2 would prescribe. So it's when you think about adding up an extra 30 CFM per apartment, and you do that over a 30 apartment building, all of a sudden you've greatly increased the size of your equipment. So I steer people towards that simple formula when we're looking about, just when we're talking about the flow rates that are needed for apartments. Um, do I want to say anything more there? I think I'll leave it at that. I will add one piece of information about when we're sizing equipment, particularly when thinking about these large rooftop central systems. Um, and, th and this is just going to get more into, this isn't really code, this is more just sort of best practices, just like a little FYI. So when we're sizing equipment, if you needed 1,000 CFM for your whole building, apartments, common areas, all in, don't buy a piece of equipment that provides 1,000 CFM. When they're running full capacity, they're not running at their peak efficiency in terms of recovery efficiency. It turns out, if you can slow the unit down a little bit so that you're slowing the airflow through the recovery mechanism, they do a measurably better job of recovering energy. So sort of a rule of thumb is 75%. So if your building needed 750 CFM, buy a piece of equipment that is sized for a maximum capacity of 1,000 CFM, and then you operate at 700 CFM, 750 CFM. Now you're going to get the higher recovery efficiency out of your core, and better performance. Okay, and while I've got you, again, it's not code, but I'll talk about design. One design that I really like that I've seen on a few buildings recently is, rather than having the one big rooftop unit, and then you've got your duct penetration, trunks, et cetera, coming down through the roof, and you've got to go down through floors and deal with fire dampers and all that, is seeing a smaller ERV on every floor. So you're no longer running penetrations through the roof. You're no longer running ductwork vertically through floor assemblies. So not only are you not having to deal with fire dampers, but you're also not having to fight the stack effect when it comes time to try to balance these ventilation systems. So I love that idea of a, still not like the big large one on the rooftop, but a smaller one on every floor level that is located in a closet, and now you're just running horizontal ductwork. But I digress. Let's get back to code. CBES has a little section that talks about air source heat pump equipment sizing, and this is new for the 2024. And saying heat pump equipment shall not be sized greater than the calculated peak heating and cooling loads. And this stems from the fact that we've learned, painfully so in many applications, that these air source heat pumps are significantly less efficient when oversized. So they will short cycle, they'll come on, they'll shut off, come on, shut off. And that absolutely destroys the efficiency of them, as well as it's really hard mechanically on them. So code is making a point to say these things need to be sized appropriately. Also, that another point of this is outdoor condensing units that are serving multiple indoor heat pump units shall be sized equal to or less than the total capacity of the indoor units. So again, trying to get away from that oversizing issue. And so here we have some alignment between CBs and RBs regarding electric resistance heating equipment. So in the past, RBs has allowed, excuse me, electric resistance heating. I'm thinking we didn't really see it in multifamily buildings, but for single family, it was allowed by code. But in 2024, it actually is only now going to be allowed under certain circumstances, and this applies to both RBs and CBs. So you're allowed some electric resistance heating equipment if cold climate heat pumps are the primary heating system, and there are a couple caveats with this as well, that the supplemental electric resistant heat operates only at temperatures of 5 degrees or lower, and the building has tested air leakage of less than 0.15 CFM50. Which, interesting that language is still in there because that's actually what the code requirement is now. But I think that's a holdover from what was published in the 2020 CBES. So there we go. We can have little strips of electric resistance under a window, etc. And another instance where electric resistance heating is allowed is, so say you didn't even want to install cold climate heat pumps. I'm not sure how you do cooling, but if you wanted to heat your building with electric resistance only, you are allowed as long as you can hit this metric. So it's multifamily buildings with heating loads that are less than 6 BTUs per hour per square foot at design temperature. So if you knock your thermal shell out of the park between R value and air leakage, you are allowed to heat your building solely with electric resistance, which could be a massive cost saving depending on what your approach is for providing cooling. And something I want to make sure I call out here is that in any of these circumstances, you need prior approval from this, just in BED, you need prior approval from BED to install electric resistance heating. So make sure that you're having a conversation with them if you're considering some type of electric resistance as part of your design.
Steve,
Yeah,
quick question. How do thermostats work with backup heat? Are there two systems required to be tied together?
yeah, that's essentially it. So the ways I've seen it done is that there's an outdoor temperature sensor, and that is what essentially allows the electric resistance. Essentially, it doesn't allow the electric resistance to come on at when temperatures are above 5 degrees Fahrenheit outdoors. And there's a half dozen ways of doing this. Daikin, I think, they manufacture a thermostat that will sort of regulate both the electric resistance and the heat pump. There are aftermarket options as well, but I'm typically seeing it. I shouldn't say typically. I've seen it done a couple of different ways. I've seen some where it's just the electric resistance has its own control, but it's tied to that outdoor temperature. That takes a lot more tenant education to let them know that, hey, you know what, you might be trying to turn on that little baseboard there, but it's not going to come on unless it's 5 degrees or lower. That's a challenging conversation for a tenant to remember, particularly, they move in September or June, and it's December and they're trying to turn it on because they're a little cool and they don't understand why they have no heat, and now you're getting no heat calls. It's simpler to the tenant if you make it just sort of one thermostat that's going to control the two of them and be able to talk with the two of them. Okay, enclosed parking garage ventilation controls. Previously, the 2020 code, it was you had to monitor for carbon dioxide. Now the sensors must detect nitrous oxides as well. And there are some exceptions for garage ventilation systems that are unconditioned. So if you have an unconditioned garage and the total exhaust is less than 4,000 CFM, then you don't have to have the demand controlled ventilation in your garage. And similarly, excuse me, if the garage area to ventilation system motor nameplate power ratio exceeds 1,125 CFM per horsepower. Not a big change, but just, again, something for people to be aware of. Duct insulation did change the requirements, and there weren't, well, I'll just focus on, I'm saying CBES duct insulation because it was called out previously in terms of what you had to do with your ducts. So R12 insulation were located in unconditioned spaces, and that used to be R8, and now calling for R20 insulation were located outside of the building, and 2020 CBES was R12. I haven't seen a duct located outside of a building in an awful long time, and I really don't see that many ducts anymore in unconditioned spaces. Seems like since we have moved largely to flat roofs for our large multifamily buildings, I don't see attics with blown insulation and then ductwork above it anymore, or that's very rare now. And Arby's, all they say about duct insulation is says no duct insulation outside of thermal envelope, and I think what they were saying is no ducts outside of a thermal envelope, period. Okay, let's hop into electrical power and lighting systems. Dwelling and sleeping units are now required to have 100% LED lighting. That's not a big lift. We're pretty much seeing that anyway. I think it was, can't remember if it was 75% or 90% in the previous code. It was a high number before, but now it's 100%. Parking garage lighting has a new lighting control requirement. Most parking garages I've been in, I typically see fixtures that are on motion sensors that will dim to 50% or so. A few still have lights on that are just on all the time, 24/7, but there's a lighting control requirement there now. Lighting power density for the CBES buildings. So we're talking about common areas like corridors, stairwells, laundry rooms, community rooms, etc. Lighting power density improved approximately 15% more, but it depends on space type, etc. But this is still a very achievable watts per square foot standard. I'm not, when I've looked at buildings over the last few years, none of them looked like they were in danger of not hitting that. Energy monitoring is now required in buildings greater than 25,000 square feet. EV charging stations must be level 2 chargers or better. So level 1 is no longer allowed. We'll chat a little more about this, but level 1 again is just your 120, a little plug in the wall that you would then plug into your car. So those are no longer permitted under the code. There are some revised requirements for the charging stations and the future readiness of spaces to accept the EV service equipment. Yeah, here we go. In CBES, dwelling unit electrical meters. So in 2020, the code said each dwelling unit located in a group R2 building shall have a separate electrical meter. And there were I think the only exception that was in there was for senior facilities that were sort of multifamily. But there is a new exception in the 2024 code, and it says buildings where a majority of the living units serve tenants at or below 80% of area median income. So for those buildings that are deemed affordable, you are allowed to master meter those buildings.
We have a question about duct insulation when you get through this section.
Well, let's do it. I'll pause there.
Okay. Does the duct insulation requirement include mechanical curbs on a roof?
Great question, Bryn. Please write that one down. We'll address that in the follow up. I don't know. off the top of my head.
Bonus points for stumping Steve.
Yeah, exactly. Yeah, that's not hard these days. So yeah, stump away.
Thank you.
Yeah, great question. And again, love the questions because again, the ones that I don't know, it helps make these presentations better. Um, where was I? Okay. Yeah, so we heard electric meters. That's what CB says. RB's 2020, there were no requirements around individual electric meters, but now 2024, it's great. It aligns with CB's. So if you have a multifamily building, plan on individual meters for every unit, unless it's an affordable, 80% affordable. All right, so we're going to hop back to energy monitoring because what we just talked about is going to play in here. So again, buildings greater than 25,000 square feet shall be equipped to monitor, record, and report energy consumption. And there's a little footnote in code that talks about, so what does that mean? What do we need to be monitoring? And so when I look at that list, it says total HVAC system, interior and exterior lighting, plug loads, electrical vehicle service equipment, process loads, building operations, and other miscellaneous loads. So it's like it reads everything. So what are you going to monitor and report energy on? Everything. That's really what it kind of comes down to. But here we go. There's an exception for multifamily buildings and individual tenant spaces, provided that each space has its own utility service and meters and has less than 5,000 square feet of conditioned floor area. So I don't see many apartment buildings that have 5,000 square foot apartments, so we can ignore that one. But if we go back to the first bullet, so if you are I'll call it a market rate multifamily building, and you have individually metered all of your tenant units, you do not need to do energy monitoring. So it really ends up being that the buildings that need to do energy monitoring are ones that don't have. Essentially, if you master meter your building, you need to do energy monitoring. That's the takeaway here. Okay, CB's electric vehicle power transfer infrastructure. Okay, so if we look, so this has changed from the 2020 CBs. The 2020 CBs was, if any of you ever had to dive in to determine the number of EV spaces that you needed, it was a convoluted process, and I'm happy to see that that's been revised and it's a much simpler process now. If we look here at this table, we look down the left side, commercial building occupancy. Multifamily buildings are group R2, excuse me. So that very bottom row, and you'll see that we ignore the EV, we ignore the percentages of spaces, and we go over to, actually, let me back up for a second. If we start looking at the column, so EVSE is electric vehicle service equipment. And so it's saying that there needs to be no spaces have to have electric vehicle service equipment installed. Now let's move over to the next column, EV ready spaces. And it says group R2, 0% for EV ready. But then it says, now if you look, EV capable spaces. So it looks like, again, the way code reads, that for multifamily buildings, that's where we're landing. And so that it says determined in equation 4-11. So here is the equation, and it's essentially based on the number of dwelling units and sleeping units, and it's based on the total number of automobile parking spaces provided. And using that formula, it will tell you the number of EV capable spaces that you need to have. And we're going to get into those definitions here in a second. And I know this is in a future slide, but I'm going to bring it up here as well, that in parking garages, because of fire and life safety concerns of putting a charging equipment, and for putting cars with batteries underneath a building, fire and life safety is drawing the line to say, you do not install these in parking garages. And so even though we have this formula here, it's, if all your parking for your building is in the parking garage underneath, then you can ignore this. And I'll show you that exception here in a little bit. Okay, so let's talk a few definitions.
Before
So again,
you, before you just get too much further in here for a second,
yeah,
had a question about energy monitoring. So if, a building is 80% affordable, is monitoring required? And, it seems like there might be some qualifiers that if it's less than 5,000 square feet, then it is not required. Is that correct?
it is. So that 5,000, so let me back up for a second. Um, so hang on, electrical meters, right? So we'll walk through it again. So we've got, it really comes down to if you have a building that is 80% affordable or more, um, you have the option of master metering that building. You could still install individual meters, but you have the option to master meter. So now we get back to the energy monitoring. And if you master meter your building, you have to do energy monitoring. The exceptions are, so it's telling you the exception section, the exception says if you have individual meters on every tenant unit, and each tenant unit is less than 5,000 square feet. It's not 5,000 square feet of building area. It's 5,000 square feet of tenant space. Meaning, yeah, that's how that read. That 5,000 square foot had to do with the apartment size. So master metered, you have to do energy modeling, energy monitoring. Or if you had apartments in your building that were greater than 5,000 square feet, which seems weird. It seems huge.
So,
I want
so
to
if
rev
you master meter affordable, then the individual metering exemption doesn't apply.
correct.
Okay, great.
I think I just
And
muddied the
then
waters there.
I think it's,
Master meter energy
yeah,
monitoring.
yeah,
Individual meters, no energy monitoring. That's
got
that's
it.
that's how to think about it.
A couple more questions. So is monitoring only required if over 25,000 square feet?
Yes. So there it is. So if your building is greater than your total building size is greater than 25,000 square feet and it's master metered, then you have to energy monitor.
Sounds like we need some symbolic logic or something to map this out.
I know, it's making me think I might put this in a table.
Yeah, that might help.
Yeah, I think it would.
There's another question. It's not related to energy monitoring
Okay.
per se. In the allowance for electric heat, does the less than 6 BTO per hour per square foot threshold include the ventilation load?
I want to say yes, because that would make sense to me, but I don't know from a letter of the law. So please write that one down too, Bryn, and I'll do some digging.
Got it. I'll add it to the list.
Well, this is growing.
The list is growing. That's
Any
it for
more?
that's it for the moment.
Okay. Okay. Electric vehicle power transfer infrastructure. So level one chargers, which again, it was just your 120 plug-in. That's no longer permitted under the new CBs. Level two chargers, when we're talking about that, CBES has identifies minimum charge rates specified that make this the minimum requirement. And I think level two is 3 to 8 kVA, or you can install what's called a fast charger or a level three charger. I'm not going to spend much time on that because, well, oh my God, we're already at 8:37. Okay, here are some of those definitions from that table. EVSE, so electric vehicle service equipment space, an automobile parking space that is provided with a dedicated EVSE connection. EV ready space, a parking space that is provided with a branch circuit and either an outlet, junction box, or receptacle that will support an installed electric vehicle service equipment. And then EV capable spaces. This is the one that showed up for our group R2, which is our multifamily buildings, is that all of the requisite infrastructure is in place within 5 feet to allow a future installation of electric wiring and connection to power for electric vehicle service equipment. And what that looks like in terms of real world design, I'm not a designer, so I don't know, but these are the definitions that we've got to work with. And I think there is better guidance probably in the code about some of that, some of the design characteristics. There's our table again. I don't think we need to focus on that. We don't need to focus on that. Okay, here we go for electric vehicle capable spaces. R2 occupancies with multifamily building garage or covered parking. I'd forgotten that piece. So that's the exception. So covered parking, garages, etc. You are exempt from creating the EV capable spaces. Let's see, there is a requirement in CBES for additional electric infrastructure. And I'm only calling this out because multifamily buildings are exempt from this. And so I'm just making you aware that as some of you are probably starting to play in the new code and looking at it and you come across the additional electric infrastructure section, be aware that multifamily buildings are exempt. And there's a bunch of this additional electric infrastructure I'm not going to get into here. That's because it's not going to apply to multifamily, but it's a fairly significant section in the code. Let's see. So Arby's has slightly different requirements than CBES does. So here's one of those cases where depending on your 3 stories or less, 4 stories or more, you have to treat your EV stuff differently. Or actually, no, this ends up being the same. The wording is different. The formula works out the same. That's right. I'm remembering this. So for multifamily building, it's saying 1 per, for talking about EV capable spaces, 1 per dwelling unit, or the number of parking spaces provided, whichever is less. And then additional parking spaces, 25% of remaining parking spaces not utilized by dwelling units, or 40 spaces, whichever is less. This effectively ends up being the same as the formula that you see in CBES. That's what I want you to walk away from here, that they do have the same requirements. And in Arby's, this applies for both base and for stretch. So with regard to electric vehicle capable spaces, there is some work that has to be done in terms of providing the requisite information on electrical drawings. And I also see that you need to show appropriately sized pathway to the building electric room to accommodate future upgrades, provide adequate floor wall space and electric room for future EV charging related equipment, quantity of future level 2 EVSE charging stations per the previous table. So again, someone just has to be thinking about that table, and that the design has to reflect, even though you don't have to install the actual charger itself, you have to show where all of the infrastructure is going to be. We don't need to talk about additional electric infrastructure. That is something that doesn't apply to multifamily. Okay. If you remember from the previous code cycle, we had, I'll call it prescriptive plus points method for demonstrating compliance with the codes. And so we would go to, for instance, the CBs, we would go to chapter 4, we'd take our R values from the prescriptive tables, and then there were some additional energy efficiency credit points that you needed to obtain depending on your building type. That principle is still in play, but the tables have changed. There are a lot more options, and the point values have been altered as well. But in addition to that, there's now something that's called the load management requirements as well. So it is a similar point-based system, similar to the energy credits, and we'll get into that. So I'm just giving you a little teaser there. So for CBES compliance, buildings shall comply with the additional energy credits, just like we used to, and the additional renewable and load management credits. So how many points does my building need? So again, here we are, we're looking at the energy credit requirements. And if we go to group R2, you can see you need to have 79 energy credits. And I think in the previous code, it was 3 or 5 or 6. It was something small. So again, the point scale is entirely different with this. And mixed occupancy, so you've got commercial space first floor, and then you've got 3 stories of multifamily above it. The guidance in code says calculate the weighted average of credit requirements based on square footage of floor area. That's how you would handle that. So here we go, energy efficiency measures and credits on the CB side. Again, group R2 is the very first column. And we have some very familiar faces in here. UA reduction, that's essentially doing better with your wall assemblies, and windows, etc. Envelope leak reduction, more, and then I'm not sure. Then they've got some that are just sort of, I'd have to look at what the difference is between UA reduction, because I would have thought that was the U value for an assembly reduction. But then later on, they talk about adding roof insulation, adding wall insulation. So there's some distinction there that I'll have to tease out. Better windows, better HVAC performance, heating and cooling efficiency improvements. Trying to see if there's anything else interesting I wanted to draw your attention to there, but there's more. And I think the one that I wanted to call out, where is it?
There's a question is, aren't these essentially stretch code?
Well, there is no stretch code. This is base code. There's only one code in CBES. There is no stretch in CBES. So we, as designers, builders, owners, et cetera, have to follow and incorporate these credits. Anything else terribly interesting in here that I wanted to call attention to? And the answer is no, just because in the interest of time, we're at 8:45. I've still got quite a bit to go. Just be aware that there are more options for energy credit measures and that the point system has changed. But here's the big change that I wanted to highlight is that there's now a renewable and load management credit requirement as well. And so similarly, how many points does my building need? And so for a group R2 building, we can see we need 16. And this is what we have now for options for renewable and load management credits. And on-site renewables, lighting load management, HVAC load management, auto shading, electric energy storage, cooling energy storage, solar hot water, energy storage, building thermal mass. And here's the one that's really interesting to me is insulation embodied carbon. And I'm going to back up for a second. So if we look at, here we are, group R2, we need to get 16 renewable and load management credit requirements. That, I skipped over all the additional electric infrastructure section, but lo and behold, if you do that, you get the 16 points. I'm going to have to remember to add that back in. I'm not going to talk about it right now because of time. If I have time at the end, I'll go back to that. But the thing that's really interesting to me is that the code for the first time is in writing calling out embodied carbon, and that the need, that really the why we have the energy code and why the energy code has cycles and moving towards a net zero construction scenario by 2030 is really getting at the heart of reducing carbon. And so insulation embodied carbon, things like Timber HV now makes a great product that is, it's wood-based insulation, for instance. There are some exceptions for, oh yeah, okay, here we go. So there are exceptions to the renewable and load management credit. So if you were to achieve an additional 70% more on the energy efficiency credits, then you only have to obtain 50% of the renewable and load management credit. I'm sorry, this is uh, unnecessarily adds unnecessary complexity to this whole process. But just know that if you boost up the percent on the energy efficiency credits you got, you can lower the amount of renewable load management credits that are required. Similarly, if you achieve 120%, an additional 120% of the energy efficiency credits, then you don't have to get any of the renewable and load management credits. So that's a pretty important distinction. If when you're looking at this table and you go through that and think, wow, we're not going to get 16 points for our renewable and load management credits, that means come back to these two tables and figure out how to get another 70% or 120% improvement in the building, and then you can avoid the renewable and load management credits. And Arby's has an entirely different approach for total required points. So again, depending if you're 3 stories or 4 stories, you've got a whole different playground to be addressing with regards to the additional energy credits.
And so regarding the CB side of things and the threshold for what puts you on the CB's requirements, those are the minimums.
Those are the minimums.
Yeah.
Correct. Yep. And so here we go. And one of the other listeners had the question earlier of, wasn't that table just stretch code? There's no stretch code in commercial, but there is a stretch code in Arby's. So as you can see here, so points are required both in the base code and the stretch code for Arby's, the 3-story or less building, and that the point requirements are different. And so you can see it's actually based on somewhat on apartment size. So if you scroll down and we look at a multifamily apartment that is, we'll call it a studio or a micro apartment, there are 0 points required for the base code. So less than 650 square feet. 1 point would be required for stretch. And then you can see as you get larger in size of your multifamily apartment, more points are required, but it's still a small number. Even the largest of the multifamilies that we would typically see were in the 2 to 4 range. And yes,
there's a requirement, or there's a question asking about the requirements as it relates to historic buildings on the state or federal registry and compliance exceptions.
Yeah, and so that is the same as it was previously. So if you have a historic building, you're going for historic tax credits, you can't just assume that code doesn't apply to your building. You have to file the requisite paperwork with the Department of Public Service and just demonstrate that here's why the building has been deemed historic. I don't know what all that paperwork looks like, but there is a section in code that discusses, I believe, how that needs to be addressed. So that is still an exception to code, is if you have a historic building that is going for tax credits. All right, so when we're looking at Arby's points, there are a truckload of ways. Again, you only needed 1, 2, or possibly most 4 points for a multifamily apartment. And I'm gonna just show you sort of these in aggregate. I'm not gonna go line by line because there's too much. There's a whole section on envelope. There's a whole section on air leakage reduction, on improving the efficiency of mechanical ventilation, heating and cooling equipment, what the types of equipment you use. For instance, if you go ground source heat pump, you get 10 points for going ground source heat pump. There's a whole section around water use and hot water, renewables, a whole section on other measures such as monitoring, radon, energy modeling. They too have a section on embodied and insulation embodied carbon emissions. And then there are some that are specific just to multifamily buildings for essentially, efficient elevator equipment get to that 1 point. Residential equipment, kitchen equipment, if it's all Energy Star, you get 2 points. Water heating system submeters. So on the RV side, it's very straightforward and in my mind, again, and very, 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 very easily achievable without having to think of too much about it. On the CB side, it's a different story. There's, again, I think we needed 79 points. So you're going to have to hit several of those categories to be able to do that. All right, we're at 853. I want to backtrack then to additional electric infrastructure because that was one of the things that it's not a requirement for because there is an exception for multifamily buildings, but it was one of the means for obtaining points on that renewable and load management credit side of things. And so I'll just sort of gloss over this because I want to make sure people get out of here on time. What do we have here? Okay, so additional electric infrastructure. So buildings with low capacity combustion space heating. So as you can see, furnaces and boilers, it's saying that installing condensate drains within 3 feet of the heating equipment and saying installing a dedicated branch circuit installed and labeled for future heat pump space heater. And where they're going with this is trying to make sure that buildings that are heated with fossil fuels today are being set up for the future so that it is I'll say, relatively easy transition to electrification in the future. So that was buildings with low capacity combustion space heating, buildings with high capacity space heating. So again, large equipment. It's kind of the same. I don't know why they made the big distinction here. I guess the thing I'm looking at, junction box, conduit, bus bar, and electric panel shall be rated in size to accommodate a future branch circuit with sufficient capacity for equivalent electric equipment. So that tells me that electrical engineers are going to have to do a little work to think about, okay, if this building were to be heated and cooled with air source heat pump, ground source heat pump equipment, et cetera, what would that design look like? And let's build that into that equipment that's installed, like the branch circuit, et cetera, and at the electric panel. And again, I'm going to keep saying this. This isn't a requirement for multifamily buildings, but it is one of the methods for obtaining load and renewable and load management credits. That's why we're discussing this here. So there needs to be other combustion systems with similar circuit and signage requirements as for combustion heating systems. So again, service water heating, if you have, picture you've got a propane or natural gas fired, direct fired domestic hot water system, you need to put in, so you need to essentially future proof for future electrification of the domestic hot water system. Commercial cooking appliances, commercial clothes drying, residential clothes drying equipment serving multiple dwelling units. So and that would be the case when you have natural gas dryers, for instance. Okay, we squeeze that in. It's 8:57. I'm going to stop there. And whoop. Why did it pull my it stopped the slide presentation and hang on 2 seconds.
There you go.
There we go. Just so you've got my contact information, and we landed the plane on empty here.
Yeah, great job. There was a hand up. Sorry, if you want to raise your hand again, we can get to it now, but another question in the chat, what happens about when renovating an existing building that is not historic? Are there compliance requirements for CBs?
Yeah, and it really comes down to what have you done? It's if you're renovating an existing building, it's sort of system by system, meaning code will tell you code isn't going to force you to do some things. For instance, if you're renovating a building, you don't have to bring the walls up to code. If you were to, it's not saying you have to tear off your siding and add a bunch of continuous insulation. What it would say is if you're taking sheetrock down on the inside of your building, uh, you just have to code would say you just have to make sure you fill the cavity. It's not going to be because it might not physically be possible to bring it up to what code requires. Say there's no existing continuous insulation to the exterior. Code would just say you just have to make sure you're filling the cavity. Um, Things around lighting, it's similar. If you're let's talk about your corridor lighting in a multifamily building. If you said, hey, you know what, we're just going to go replace fixture by fixture, and we're not going to change the controls, or we're not going to change the wiring, then it would say all you have to do is make sure you're installing an LED product. If you said, yeah, you know what, we're going to completely pull down the whole electrical system in the corridor because the lighting really wasn't sufficient, so we want to relight, then it would say bring it up to code, and then you'd have to look at lighting power density just to make sure that you were in compliance with code. So it really has that. I hope those are two examples that I'm hoping cover your question, and ask a follow-up if I didn't.
Can you provide the CB section that exempts parking garage EV charger requirements?
Yes, Bryn, could you write that one down too, please?
Sure.
And I will put that in the slide. All of these questions I'm going to put into the slides, the answers of the questions into the slides, but I'll also call them out in the email as well in terms of here is the question, here's the response, just so that if people don't want to go dig through slides, it'll be there.
Great.